Hello everyone, my name is Dr. Harvey Miller and welcome to our lecture on process strategy as part of our course on operations management. Now, all of us consume goods and services, all sorts of goods are in our lives, computers, whether it's our stereo sets, kitchen appliances, and so forth, or we consume services. We go to a restaurant, we go to a doctor, hospital, all of these sorts of situations. So in all of those, the product or the service would have had to have been created. And so how do we create these products and services? Well, these products and services get created through processes. All right. So we are going to focus on the different types of processes in order to understand that. What are their relative benefits, advantages and disadvantages, and how we find ourselves when we are designing an operation system having to make choices between various types of processes. So having process understanding as well as understanding the capabilities of a process will help us to be able to align the operation system with the vision and the mission of the organization. All right. So in this particular lecture, we're going to talk a little bit about different types of strategies. We're going to talk a bit about process analysis and design. We're going to talk a bit about special considerations for service design and the use of technology in services as well as process redesign. Process redesign in the 1990s was a very big thing because companies wanted to improve their productivity. They wanted to improve the quality of the products and services that they produced. And because those emanate from a process, it meant that if you wanted to improve productivity, you had to take a look at your process. If you wanted to improve quality, you had to take a look at your process. So let's get started. In terms of understanding these different types of processes. So when we finish, we're hoping that we understand different types of processes better. There are four sort of core categories for processes that we will consider. We'll try to understand the concept of crossover points. And crossover points have to do with if we have to make a choice between different types of processes that have different fixed costs and variable costs. At some point, they will cross over, meaning that one below a certain volume of production, one process will be more cost effective. Above a particular volume of production, the other would be more effective. If the two processes have the same fixed costs and the same variable costs, of course, there's no choice to be made. Either one, just close your eyes and pick one. But if they have different variable costs and different fixed costs, then typically you end up with a crossover point. So we will learn a bit about that. And then some of the tools that we will use in process analysis and sort of discuss the concept of customer interaction in a service. All right. So let's just start off with the idea of a process flow. So if we're making a product or a service or producing a service, then often there's a series of steps. This diagram for us shows producing a motorcycle. So you could see that as we go through this example, that there are various stages. So here we're talking about frame tube bending, which is some aspect of the production. I've never made a motorcycle, so basically we just have to assume that that's how it's done. Then we go into build frames in work cells. The production of a Harley Davidson is done in a very kind of like custom shop sort of a way, not heavy repetitive manufacturing that has assembly lines and so on. It's kind of like almost like the reason why you pay so much for a Harley Davidson, because it's almost like it's built in a craft kind of a way. All right. So you'll have to machine the frame, hot paint frame painting, using hot paint and so forth. And then, of course, you see the process continues here into the various things that have to be assembled, right? Air cleaners, oil tank, wick cell, fluid and mufflers, shock and forks, etc. So these are all the various parts that have to be put together for the motorcycle. And after that happens, here's something else. The engine arrives on a just-in-time basis. So you're sort of taking the frame part of that. This part has to do with the frame, right? And then you have the engine right here. And you bring those together and then go through the assembly of these various pieces. And then we come to the stage where we're testing. After you test, hopefully you have a bike that's working. You create it and then you take it to your customers via a warehouse or distribution center and so forth. All right. So this is just an example. If we were to think about services, if you think about going into a restaurant, you enter, sit down, a server comes to you, provides you with a menu, you place an order, your food is being produced in the back, then it's served to you, you eat, and then you get a bill, pay your bill, and then you leave. So there are a set of steps as well in a service process. All right. So process strategy. So the idea is that we focus on processes to bring about alignment between operations and the mission and vision of the organization. So the objective of a process strategy is to build a production process where not you're producing a product or a service that meets the customer requirements and product specifications within a cost and other managerial constraints. We may have managerial constraints such as, well, we could only accommodate X number of units of inventory at any point in time. So that means that even though you may have the capacity to produce more than the inventory limit, you only have space for X amount. So there's a managerial constraint that says no more than 50 units per day because that's all we can store, even though you could produce 100 units per day. All right. So that's an example of a managerial constraint. The other thing too is you may not want to produce more than you need because then inventory will cost you money. And you don't want to have a situation where you have excess inventory because excess inventory sometimes could mean obsolescence and just money tied up in a physical good that only gives you a return when you sell it. Okay. So let's look at the relationship between process, volume, and variety. That's a very common discussion when we think about process strategy and process management. Is what is the capability of the process? What kind of volumes we could get from it? What kind of variety we get from it? What kind of speed? And so we're going to talk about different types of processes because to produce different types of parts, you need different types of processes. So there is one process that is called a process focus kind of organization, factory. In a process focused facility, you have various processes and the product that is going to be produced will require a subset of those processes, not all of them necessarily. So in that environment, you tend to have, because you're not mass producing, you tend to have low volumes, all right? But you have a lot of variety. A very good example of a process-oriented facility is a hospital. You know, we come into a hospital with different ailments. Given that we have different ailments, every single person doesn't go through the exact same process. We might all register, but I might have a chest problem, in which case I need a chest x-ray. Somebody may have some other kind of internal problem that requires blood work. So there's an area that processes the blood work. There's another area that processes that will do the X-rays, and so on. So the path that you take in the hospital will depend on the kind of diagnostic that has to be performed or the kind of service that you need to receive. We refer to those kinds of facilities as job shops. If you go to say, at one point in time, there were these copy centers, that provided photocopiers, staplers, cutters, and so on. And so a lot of people came into these centers to do document processing. There were computers where you could do printing, color, black and white. So all of these stations were set up. There's an area where you could go cut your paper. There's an area where you could print. There's an area where you could go onto your computer, upload your files, and then do some editing before you print it out. So all of that, these were sub-processes. And images coming out, all I want to have is my document binded. Somebody else might actually want to have a document printed but not binded. So that's an example of a job shop. You have variety, but you have low volumes, all right? The Kinkos and those sorts of types of facilities. Then you have slightly higher volume. You notice that volume is increasing this way, and flexibility is actually increasing this way. So you have low volume, high flexibility for process focus types of facilities. And then you have sort of a moderate variety, moderate volumes for repetitive types of organizations, such as manufacturing appliances, right? Stoves, dishwashers, motorcycles, automobiles, and so on. So in a case like that, we say repetitive because there's often a variety of styles. There is a production process that you keep repeating, but it may look very similar for the styles. Like if you're making a refrigerator, there's a set of steps to produce a refrigerator. But if there's a 5 cubic foot or 8 cubic foot, I'm not even sure the exact sizes of refrigerators, then or the style might be a little different, in which case maybe you have a single door versus double doors. You have the freezer on the top versus the freezer on the bottom, and so there's some variation in terms of styles, but the process is relatively repetitive. And you could produce, when you're producing one style, you could produce at a sufficient volume, but not like the mass production, like producing beer or bread and so forth. So we call that repetitive strategies. So what you're noticing is that there's a compromise between volume and flexibility, or volume and variety. So we move to the center, we have moderate volume, moderate variety. And as we come here, this is what we call the product focus kind of manufacturing, where you're producing an item in really large quantities, and your product and your number of styles don't vary that much. So there's little variety. As we could see down here, variety is low, variety is high, right? Volume is high, and then volume is low. So here we have high volume, low variety. All right. And so if we're making something like bread, that's an example of that. Or making chips, potato chips, very, very high volumes. Now, if you were to think about a facility like a McDonald's, for example, what kind of process would we call that? Would we call that a process focus, repetitive focus, or product focus? Well, it's not process focus because making a burger, for example, does not have multiple routes or routes, if you wish. A product focus, we're not producing the kind of mass volumes where you just have burgers just coming on or in very high volumes. So repetitive focus, where every time somebody places an order, we're making a burger over again. But then there might be slight differences where now we want 2 patties instead of 1. We want cheese, or some have no cheese, onions, no onions, ketchup, no ketchup, and so on. So in a case like that, that would be considered much more of a sort of a mid-volume, mid-variety. And you would have a repetitive focus in that case. All right? So, 4 process strategies, we're going to talk about that. So essentially helps us to answer the questions about how to produce a product or provide a service that meets or exceeds our customer requirements. It meets our costs and managerial goals. And the managerial goals may have something to do with being competitive. So if you want to be cost competitive, if you want to compete on flexibility, if you want to compete on speed, if you want to compete on variety, then your operation system has to assist you with that. And your processes will have to be appropriately aligned to allow you to achieve that. All right? There are long-term effects on efficiency, production flexibility, cost and quality as well. So these are some of the implications of your process choices. So the 4 basic process strategies, and I just realized I missed one, which is this one right here. Let me just go back and talk about it, although we'll get a chance to speak about it some more. I just realized that I missed that one. So if we look here, this is an interesting situation. So companies were always looking for an opportunity to have both volume and flexibility, or both volume and variety, right? Because, in your traditional manufacturing, there's a trade-off. If you want high volumes, then you're going to have low variety. If you want to have high variety, you're going to have to be looking for low volumes. But can we have high volumes and high variety? How do we do that? Well, you can. And one of the early sort of adopters of this concept of mass customization was Dell Computers. So there's all kinds of articles written about Dell Computers. So if you really dig deep into mass customization, what it is that you get your volume by using either a repetitive process, all right? But then you get your flexibility or your variety by having what you call modular design. So modular design. So if you think about computers, for example, if I have, say, a 13-inch computer, and all I have to do is to just change. If it's a 1 terabyte computer, and say I have a screen resolution, a particular screen resolution. Well, if I have 3 screen resolutions and 3 hard drive sizes, 1 terabyte, 2 terabytes, 5 terabytes, then all of a sudden that is 3 multiplied by 3, right? Gives me 9 different computers. But they are all going into the same 13-inch computer. All I have to do is to pull out the slot and slip in a 2 terabyte drive. Pull out, slip in a 5 terabyte drive. So if I did that, then essentially that's 3 different computers right there. A 1 terabyte computer, a 2 terabyte computer, a 5 terabyte computer. And then now, if I change the, say, the process speed, for example, 1.5 gigahertz versus 2 gigahertz versus a 2.5 gigahertz, then in that case, that's 3 options. So I could have a 1.5 gigahertz with 1 terabyte, 1.5 gigahertz, 2 terabytes, 1.5 gigahertz, 5 terabytes. That's 3 computers. So that's how you produce the variety, and you have a design that could be manufactured in a repetitive fashion that gives you the volume, the speed, and the high volume that you're looking for. And the time it takes to swap out one drive and put in another is very small. So not a big deal. All right? So let's talk a little bit about some of these aspects of the various types of processes. Facilities are organized around specific activities, right? As I was saying to you, copying, printing, etc. General purpose equipment is used so that a photocopier, for example, can copy a color page, can also copy a black and white page, can copy 8.5 by 11 page, an 8 by 4, sorry, 8 by 11, or 8.5 by 11, or can do an 8.5 by 14 page, right? Legal could do A4 paper, A3 paper, legal paper, leather. So that's basically gives you that flexibility. So there's a high degree of flexibility, typically high cost and low equipment utilization. Because you want to have that variety, then you may not get high volumes to give you high levels of utilization, but you are very flexible. And then product flows may vary considerably, making planning and scheduling a challenge. So when we think about different people coming in with different types of jobs, you don't know, unless you have a really good forecast of the kinds of jobs coming into your facility, you really are not sure on how to actually do this. So this is just an example of, if I were to look here, you will see that you have these different workstations, right? Different individuals, and excuse me, those would constitute your different areas, or your different process areas. All right. So process focus, different people, you have different demands, and then of course the route that a product takes come in here. It may go to here. It may very well go across here, come through here, and then come out. Okay, that could be the path of one situation right here. Repetitive focus, often organized as assembly lines. So you have, if you're producing an automobile, for example, you will see an assembly line where the car is going along the line, but then the parts or the components are being assembled on it. Now, of course, you have to give people time to assemble the windshield, the wheels, the rotors, etc. And so therefore it takes time. So you're not going to get that kind of speed of a product-oriented focus, but it is repetitive in the sense that we will repeat that for the different types of cars. But a car could be a hatchback, it could be a station wagon, it could be a sedan, it could be an SUV. And so there's similar aspects to the process. So here's a car coming along an assembly line, and then the different parts being added to it as it goes through. All right, the repetitive. So that's the repetitive focus right here, and we talked about it in the context of a Harley Davidson, as well. So you have your all of your raw material coming in. You have few modules, and then you produce those out. So internally here, you have some assembly line systems happening. I mean, where the product is actually, the different types of products are more or less going through a relatively similar process steps. All right. The product focus is facilities are organized around a particular product type. So if you're making beer, you don't, you have the big vats or whatever it is. You don't change that, right? You don't change that for each different product. You will change the recipe, but then it goes through whatever the stages that it has to go through. It will pretty much go through that. So you could produce large volumes and so forth. If you're making chips, you got to fry it. You got to, well, first of all, you create your whatever it is, your mixture, and then you extrude the chip, and then you run it through a fryer, and so on. Let me see if I could get you a picture of that. Oh, I gave you one of bread instead. I prefer bread to chips, so and these look pretty nice. So anyway, as you can see, look at the volumes. Look at the volume here, and so you could see that quite a bit, right? So yes, so your bread factory, your sort of mass production bread factory, is a product focus type of organization. So high volume but low variety of products, long continuous production runs to get efficiencies. All right, so you might be running that for a couple hours to produce, thousands and thousands of bags of chips. Typically very high fixed costs, low variable costs, and generally less skilled labor. You just need someone to have the settings on the equipment, and then once you press the button and let it run. Okay. All right. So mass customization, as we said, rapid, low-cost production of goods to satisfy increasing unique customer desires, and combines flexibility of a process, right, with the efficiency of a product focus. So it's really a combination of these extremes, variety and volume. We already talked about that, and you might say, well, is this mass customization? Well, the fact that you have a repetitive focus, so you get some of the efficiencies, but then you have some variety, in which case you could actually place an order for a car where you say, I want it to be manual, I want it to have satellite radio. So you could actually custom order a car if you wanted to. And your manufacturer can actually do that, because the way in which the facility is organized, it actually allows them to be able to customize the car for you without actually any major loss in productivity. One of the important features of mass customization is that you could actually produce relatively low volumes if you needed to, without too much loss of efficiency, right? So mass customization has led to increased volumes. Of course, that also means that increased consumption. And if we have increased consumption, what does that do to the environment? So while we say we created technology that allows us to customize things, we are also, as a result, producing more products, more variety, and we are actually end up polluting the environment a whole lot more. All right. Mass customization. Just recently, there I ordered a pair of glasses. I went online, fill out my specs, my prescription, and voila, it comes to me customized to what I want: the color, the frame, the actual lens specifications, and so on. And so 1,000 people can actually do that. So that means that the company that's producing the glasses could actually customize for a mass audience, a mass consumer situation, in which case they are mass customizing. Bicycle manufacturers can do that. They actually provide interfaces that allow you to specify the height of the bike, the color of the bike, the weight of the bike, the kind of material, and so on. So mass customization is now fairly common, and it's with us. You could actually go and use templates. That's what templates allow you to do. If you want to write a book very quickly, then go on a template and customize the template to your needs and produce your product. Same thing with restaurants, McDonald's menu items. So through customization, you can actually have a variety. So the same burger with fries, without fries, with ketchup, no ketchup, 2 patties, 1 patty, etc. That's customization for you. All right. So mass customization, as I mentioned, sort of blends a bit of all of those things, where it uses modular techniques. You have to have responsive supply chain. You have to be accommodating in terms of your product and process design to give you that balance between flexibility and variety. You get the sort of volume from your product focus, and then the variety from your process focus. All right. So Mass customization, as we said, is must produce a lot of opportunities for manufacturers, but there is the downside in terms of us producing just way too much and then too much consumption that then ultimately has a negative impact on the environment because we have to dispose of these items. So it's imaginative, fast product design, rapid process design, tightly controlled. Inventory management is needed. You need tight production schedules and you need a responsive supply chain partner. Why? Because if you have different customers ordering different things, you cannot now stockpile raw materials. If you're offering people, for example, okay, you could get it done in metal, aluminum, or you could get it done in carbon fiber, right, or some other form of plastic, then you would need to be able, depending on your orders, be able to get a supplier that could respond to your needs very rapidly. All right. So let's look at a comparison, just a few of the comparisons of the the various processes. We have things like if we compare process focus, such as like a hospital, repetitive focus, the manufacture of a car or Harley Davidson, product focus, manufacturing of chips, Frito-Lay, and mass customization, the Dell computer. So in a process flow, we know that small quantity, large variety. In a repetitive focus, we tend to have longer runs, but usually, interestingly enough, a standardized product with a few options, right? And then we have large quantities with very small variety of products, and here we have a combination of the two. In terms of the type of equipment used, general purpose equipment, special equipment used in an assembly line, equipment used is special purpose. So if we're brewing beer, you can't turn around and use it to manufacture chips. All right? And then you have to be able to have rapid changeover on flexible equipment. So if you're mass customizing, if in my case, I'm asking for black frames, round rims, according to my particular lens requirement, then somebody else with green frames, square rims, the production process have to be able to accommodate that. So you're going to need some rapid changes. All right. The operators are broadly skilled when you're talking about process focus. Here, in terms of repetitive, they're modestly trained and the operators are less trained. Now you need flexible operators who are trained for customization purposes, of course. There are many job instructions based on the different types of processes. Repetitive one reduce the training and changes in job instructions. So there is some training that's necessary, but because of less variety and standardization, you don't have as much training that you have to do in that case. And then you have job descriptions or job instructions are fewer in this case because the product is highly standardized. Custom orders will require many job instructions. So for each type of order, you will have an appropriate type of job instruction. And then raw materials, inventories tend to be high because you need to be able to satisfy variety. Just-in-time procurement is possible in the case of repetitive focus. Raw material inventories are low relative to the value of the product or the volume of product that you're producing. And then raw material inventories are low relative to the value of the product in this case, right? So because you have some standardization here, you do actually have some standardization that comes from your repetitive focus. And so with standardization, you could actually manage inventory pretty well, all right? Work in process is high compared to the output, and where basically with the sort of process-oriented kind of organization that you tend to have between the various processes, you tend to have work in process, meaning that things that are incomplete. And because you have such a wide variety, you're going to have work in process for each of those different types of products that you're producing. So there tends to be a high level of work in process inventory, in which case it costs you money because to have inventory high that's actually a cost to the organization. You could use just-in-time techniques. Work in process inventory generally tends to be low when it comes to product focus. And remember what work in process inventory is the inventory that is in process, is not complete yet. So if you're producing chips, for example, you don't have one stage where, okay, we're going to half fry the chip and then later on we're going to finish it up. If you did that, where you half fry the chip and then store it somewhere and then finish it up, then that half fried chip would be work in process. But you don't have that. You have essentially, once you put in the raw materials, the bread, for example, if you're talking about bread is needed, shaped into the various types of shapes that whatever shape it's going to be produced, and then it goes into the oven, comes out, and then it's packaged. There's no stopping somewhere in the middle to create work in process inventory. All right, and then work in process inventory is driven down by just-in-time Kanban lean production in a mass customization environment. So, okay. All right, and then the units move fairly slowly in a process-oriented case. Assembly is measured and kind of like, it has a rhythm to it. In that case, we're talking about repetitive focus, and then of course swift movement of the units through the facility is typical for a product focus. Because move swiftly through the facility when it is when we're talking about mass customization. And the finished goods are usually made to order and are not stored, so the person passes and pick up their order. If I went into a copy shop, not a coffee but copy shop, then I go in. If I'm photocopying, binding, and then that's it. It doesn't sit there waiting for someone. If you ask the company to do the work for you, where you sent a file for them to print and then bind several copies, then there may be a very small window within which the product is waiting to be picked up. But generally, it's not something that's stored on the shelf for random customers to come and buy. Everything is customized, right? And so it's not typically stored. Somebody comes to pick it up. Finished goods are made to frequent forecasts that are updated in terms of your forecast for your washing machines, your refrigerators, your cars, and so on. And then you develop a production schedule in accordance with that. And then as well, finished goods are made according to a forecast for that final product. If you talk about chips or bread or any type of product that is made, or beer, then certainly you could have your forecast and then design your production runs around that. And then finished goods are usually built to order, because that's why it's mass customization. So as I said, in my case, my pair of eyeglasses, right? Somebody else's pair is different. Another person's pair is different. So it's built to orders. This is me. This is John. This is Jane, right? And this is Mary. All of us are placing our orders, right? And so it's built to order. Scheduling is complex versus fixed cost tends to be low. So here you could read the rest of that information, right, in your text, where you could see the differences between those when it comes to scheduling the work. Scheduling is based on various production, the models that are being produced. Scheduling is relatively simple. You just run production. And sophisticated scheduling is necessary because you remember you have multiple designs that you're trying to produce to meet customer requirements, and then because these are coming sometimes in real time, you're going to have to basically make sure that you have a good scheduling system to schedule a production so that you could actually meet the customer requirements in a timely fashion. All right. Let's talk a bit about this concept of a crossover chart. So crossover charts essentially recognizes that you have different processes, and the different processes could have different fixed costs and variable costs. So a crossover point is really where any two functions meet. So if we think about it in terms of functions, just move this over here for a second. And let me grab my yellow for that. So for one process, for example, we'll say the total cost of production, let's just call it your total cost of production, is your fixed cost 1 plus the volume that you produce times the variable cost. The variable cost 1 times X, the volume that you produce. Well, what you want to do is get to a point, the crossover point is the point at which those two things are equal in value. All right? And so fixed cost for process 2 plus the variable cost for 2 times X. So if you were to solve for X, you would have F1 minus F2 is equal to VC2 times X minus VC1 times X. If we factor out the X, then that is equal to X times VC2 minus VC1. And so therefore X would be equal to, would be F1 minus F2 divided by VC2 minus VC1. And that gives us the point, the crossover point. The point at which those two functions are the same. All right? And you could actually do that for any combination of functions. So going back here, we have the difference fixed costs, one 300,000, 200,000, 400,000 for these different processes. And then they have slightly different slopes based on the variable costs. So we see here, this is a crossover point between those two curves, right? This is another crossover point. This is another crossover point. However, if you have these three processes, what you want to do is to lower your production costs. So you're actually looking for the cheapest points. You wouldn't select this. You wouldn't look at this crossover point because you have a line there that is cheaper, which is this line right here, right below it. So you wouldn't look at that. So here is a point at which there's nothing cheaper there. So if I actually go down, this volume is good for this graph right here, this production line. And then between the next crossover point is here, which means that this one here, let me just do this. I'll paint this one red, then this one blue, and this one green. So since we're trying to minimize cost of production, so you could see that if we are less than the first one here, V1, if we are less than that, then we go with this line right here. If we are between V1 and V2, we go with this production line right here. And then if we are greater than V2, we go with this production line. So what you're noticing is that the one with the lowest fixed cost is good for low volumes, right? And then the one with sort of the second highest level fixed cost is good for intermediate volumes and very high volumes. The one with the very high fixed costs but a very low variable costs is actually going to will be the best, for very, very high volumes, because now you're able to recoup that fixed cost a whole lot more efficiently and effectively. All right, cool. There's a concept called focus processes, and the idea that you're really trying to bring focus to the product or the service that you're producing. And so you have to determine what is the point of focus. So it brings efficiency, and then it focuses on depth of the production line rather than the breadth. It's not so much we want to get a large variety or large volumes, but we want to focus on what that point of interest is. So are we focusing on customers? So you're designing a production facility to focus on customers' needs, or the product itself, or the actual service, or is it designed around a particular kind of technology? So focus manufacturing sort of takes into consideration where is it that you want to place your emphasis. Just because we start off with a particular process doesn't mean that we are not going to reconsider it at some point in time. So here's a case where we may very well reconsider our process. So in that case, is it easy to do? Not necessarily. So sometimes it can be difficult and expensive. It may mean starting over. Your process strategy determines your transformation strategy. What we mean by a transformation strategy is how you are creating the product or the service. You are transforming inputs into outputs. So the kind of process you use will have implications for that. And it's important to get that right. Otherwise, you may actually have higher costs than you need, low levels of efficiency than you want, etc. Process analysis and design. Essentially, we're talking about whether or not the process is designed to deliver what you want. So does it eliminate steps that do not add value? Does the process maximize your customer value? Will the process win you orders? And when we talk about winning orders, we mean winning business. So these are some questions that you'd ask yourself. You then do what we call process analysis to focus on trying to improve that particular process. And there are some tools that we can use, flowcharts, to help us to map the actual process and understand the various steps that are involved and how can we improve these various steps. The time function mapping actually takes the process steps but put it on a timeline so we could see how long it actually takes to complete a particular product or service. And then value stream mapping is kind of like a bit of time function mapping, except that you get a sense, you actually start right from the supplier and you get a sense of where value is actually added in your process. And the reason for that kind of approach is really to identify where you're taking time that's not adding value, and you try to redesign the process to eliminate non-value added time. So work in process inventory is non-value added time. It's sitting there waiting to be processed. Only when it's being processed, that's when you're creating value. All right. We could use process charts. Again, there's sort of a workflow. This is a process that talks about the different types of steps that you're going through, and we have some icons that we use to determine if it's transportation, if it's waiting, etc. So it is a form of a flow chart, but that uses specific icons to denote the kind of step that it is. And service blueprinting allows us to use the same flow charting concept, but in the context of services. This is an example of a value stream map where we're actually starting from the supplier, working all of our way up to the customer, all the way around here. And as we do this, we are observing there's 5 days that's waiting time here. Then processing is only 45 seconds, but there's 3 days of work in process inventory, 6 days, 4 days, and so on. So in the end, when we look at this, we see that from the analysis, non-value added time is actually 26 days. Look at the value added time where processing was actually done. It's only 140 seconds. That's nowhere near a day. That's basically 2 hours. 2 hours and 20 seconds. Not 2 hours, 2 minutes and 20 seconds, sorry. 2 minutes and 20 seconds. Yet there's 26 days in your system where you're not doing anything that's useful. So can you reduce the time it takes to for your raw materials to transit into your shop? Can you reduce the amount of work in process inventory? Can you speed up your processes so that way your products spend less time waiting? A process chart, as I mentioned to you, is essentially a flow chart, but it tells you what kind of steps that you're undertaking. So storage is this V here, D is for delay, inspection, transportation, and the actual operation. So for each step, meat party storage, so you notice that it's a V. Transfer, so that's a transportation, right? Go to the broiler itself, so that's an operation. So it just shows you how you use these icons to outline the different process steps. So we know that after this is an inspection step, right? Then it gets transported, it's stored, transported again. There's an operation which is the assembly of the order. Then it's transported, placed on a finished rack, and then the customer comes and gets it. This is a hamburger assembly. So you can kind of do the analysis to determine what's the total time it actually takes to get the burger completed, and the total operating time that the time that you spend operating, not transportation, not storage. So if you take a look at that and you see your total operating time over your total time, that gives you a measure of the utilization, the value added time that you're trying to determine as a percentage is your total operating time over your total time for the production of the good. And that's, in this case, for this example, is 85.7%, which is not bad. All right. Service blueprinting, as I mentioned to you, is just really applying flow charting to services. So here's a case of a customer coming for service. Let's see what kind of service this is. So you have here. Oh, and the other thing too, when you're doing service blueprinting, you kind of lay out 3 different, if you wish, not phases, but components of the service. A part where the customer is in control. Here where there is contact. Whoops. Contact. Customer or interaction, if you wish. And then this is back office. So it's important to be able to separate those steps, because where the customer is in control, you got to know what is it that you want the customer to be doing and design your service in that way. So for example, if you're going to pump gas, nowadays most of us most gas stations are self-service. Before you used to have people serving you and you just sat in your car and placed your order. Now you have to serve it yourself. So which means that if the customer is going to be controlled, you have to provide an interface that makes it relatively easy for the customer to commence the service. All right. So in this case, the pumping stations need to have proper interface to allow you to select the grade, enter your card information, etc. Select the amount of gasoline that you want to purchase and all those sorts of things. So the customer is in control there. All right. And then if you go inside to pay, then there's interaction. But as you pay, there's some processing that happens in the back office. There's some information that is shared in terms of being able to manage the inventory of the of the gas, the different types of gasoline and so on. These are back office operations. So when you're designing your service, it's good to actually look at it in terms of these different levels. Level 1, customer in control. Level 2, customer interact. Level 3, the customer is actually removed from the service interaction. And what happens is that understanding this kind of a layout allows you to design your process in such a way that you achieve different results in each one of them. So in the back office case, you might be able to do some automation. You can do some automation in terms of the interaction. However, if you want to influence the customer experience, what kind of interaction would you design? Is it going to be all automated, robotic? Maybe not. So you do want to have the kinds of service attendants that greet your customers, maybe find an opportunity to sell them something extra, upsell them, and and those sorts of things. So in a case like that, you have to think about the service design. If you think about not-for-profits that are providing services to communities and so on, again, they have to think about these 3 parts of the service. When the customers or the clients actually come in and they're in control, and then the kind of interaction that happens if you're providing a service at a hospital, if you're providing a service at a blood clinic, if you're providing a service in terms of legal services and so on. So not-for-profits, if you provide emergency services, that certainly will help. If you provide educational services, so you got to think about these different levels of interaction. Okay. In terms of the tools that you can use to analyze processes, we have flowcharts provide a view of the big picture, time function mapping, value stream. All of these are tools that we can use. All right. In terms of services, if you're trying to improve them, there are some considerations you may want to think about. Some interaction with the customer is necessary, but this often might affect your performance adversely. Now, it could be adverse or it could be actually positively. It all depends on the kind of customer service representatives that you have and the kind of service design that that you're offering. So simply just to say that it will be adverse, I don't think it's totally accurate. It all depends, right? The better these interactions are accommodated in the process design, the more efficient the service process will be. Of course, you have to plan for them. And then the right combination of cost and customer interaction is important. Okay? Now, in the same way that we sort of describe types of processes for manufacturing, which was the process focus, the repetitive focus, the product focus, mass customization, there is the same idea that we could, a similar idea that we could apply in the context of services. But we use those two variables. Instead of variety and volume, we're going to use the degree of customization and the amount of labor input that we need. So if labor input is high and customization is low, you could refer to that as a mass service. So commercial banking, retailing, right? Then we talk about if the degree of labor is high and customization is high, you often have what you call professional services in that category. Private banking, general purpose law firms, for example, beauty salons and so on. So those would be in that case right here. Low degree of labor, low customization. In that case, you have what we call a service factory. It's kind of like almost like the process type of orientation. So you have limited service broker service, warehouse and catalog stores, fast food restaurants, airlines, no frills. There isn't much customization in an airline in travel, air travel for you. Well, yes, maybe the customization might happen if you are an elite customer and then you're accessing the lounge. But we all sit in the same kinds of seats, if you sit in the aisle seat, whatever that is. And the level of customization may have to do if you purchase one meal versus a different type of meal for another customer. Other than that, it's the same flight taking you to the same destination, even if you're sitting in business class versus economy. All right? So no frill airlines like your Southwest, I believe in Canada, things like Flair and so on. Or you had Swoop that was providing no frills. And then, of course, you have a service shop where you have a fair amount of customization but low labor input, fine dining restaurants, right? So low degree of labor. I think fine dining restaurants should have a reasonable degree of labor input in terms of, you're not actually using robots to produce your food, but you do want to customize the meal to the taste of the person who's placing the order. So I'm not sure if fine dining is the best example of a service shop. All right. So I'm going to skip those because I just described them to you. If you want to improve services, you could do things like do some separation. The more if you could do some service separation, then you could use automation to help you, right? So bank customers go into a manager to open a new account, loan officers for loans and tellers for deposits. So that's kind of like sort of segmentation, if you wish, of the services, to improve efficiencies, because some things take a long time. Getting a loan application takes a while. So structuring services so customers go where the service is offered. Self-service, like gas stations right now. We do a lot of our own things. We place your orders online. Postponement. We got to see what happened here. I just sort of my hand slipped. Sorry about that. And that doesn't look right either. Let's go. I think this looks better. Here we go. Postponement is the idea of customizing towards the end. A very good example of postponement is if you go into a paint shop. Imagine if you had to have every color under the rainbow. You wouldn't have places to store it. But if you then have tinting solutions, then we know that combinations of tints give you the final color. So it is when you come and place the order, that's when the base is actually tinted to the color that you want. That's called postponement. If we're talking about, say, a printer at one point in time, there was a time when you had printers for different parts of the world that had different voltages, and so the printer would be assembled, and the transformer that would be put into the printer would depend on where it was going. However, nowadays we have variable transformers that you no longer need to do that. But that's just an example. That was a very good example way back in the day. You could modularize your service if possible. You could actually use automation. You could schedule it in such a way. At one point in time, we had walking medical clinics. With the large increase in demand for medical services, they've all shut down and use scheduling to kind of improve not efficiency but customer experience. Because imagine if you had 50 people just sitting in a waiting room trying to see a doctor because of the volume of demand. So now that you've been scheduled 10 minutes per person, you get your 10-minute window and then away you go. All right. Training could also help to improve service productivity as well. All right. So things like laying out your service delivery space, making sure you have the right human resources, using technology, and technology sometimes may have some complex decisions based on the capabilities of that technology. It can sometimes give you flexibility, help to stabilize your processes and give you some competitive advantage. And sometimes technology could actually allow you to expand the scope of the services that you offer, right? We could use technology in various types of services. So look at financial services, for example. We have debit cards, EFTs, electronic funds transfer, automatic teller machines, internet stock trading. So technology is being used behind a lot of those. Nowadays, everyone is talking about artificial intelligence and generative AI as another technology that could assist you in doing a lot of things. So now you don't even have to have a human being talking to a customer. Use a chatbot, and the chatbot have access to a lot of data that it then uses to provide answers to questions from a customer. You could use in education, online learning. During the pandemic, we know that how we use platforms like communication platforms like Zoom or Teams to do our teaching, right? In terms of government, you have the use of technology to automated one-person garbage trucks, and the automation sometimes come from the one person that's actually picking up the garbage is actually guiding the truck as well. You have things like mail scanners, flood warning systems, etc. Restaurants and foods, wireless orders to serve from servers to the kitchen, robot butchering of meats and so on, so transponders on cars. And then on the communication side, we have ebooks like Kindle, speech recognition, interactive TV. There's just a whole bunch of stuff that's available to us. All right. So finally, we want to talk a little bit about the concept of process redesign. There are cases where we want to improve our processes, and so if we find that we're not getting sufficient productivity or variety, or that customer needs have changed and our processes need to be improved, we would find ourselves redesigning our processes. All right. So when you are doing process redesign, the purpose really is to improve efficiency, cost, quality, There could be a whole bunch of reasons why you're considering redesigning your processes. So rethink your business processes to dramatically improve its performance. Reevaluate the purpose of that process. Why is it that you need this particular process, and are there alternatives? Question both the purpose and the assumptions, because often we've designed processes at a point in time where the kind of technology that was available was limited, all right? And so we design all the assumptions that we made about our customers and their needs and their preferences was, at a given point in time. So if we assume, for example, that customers don't like a lot of variety, then we may have a standardized process. But now that customers have been exposed to all sorts of things from all sorts of places, they're now demanding variety. So all of a sudden, you want to be able to meet those needs, and so you have to now have flexibility in your production system. All right? So focus on activities that cross functional lines. And what does it mean by that? If you have activities that cut across functional lines, it means that you have to make sure that the people who are offering the various functions to that process are capable of working together collaboratively. If you could reduce the number of functional lines, it actually helps to improve standardization and efficiency and that sort of stuff like that. And then any process is a candidate for redesign, and it may mean some cases you may have radical changes to that process, some cases you may not. Right? So in summary, process strategy can be used as a competitive weapon. Why? Because each process offers you certain advantages and disadvantages, and if you align those advantages to your competitive strategy, if you align it to your mission and vision, if it is a non-competing organization, then you could actually achieve what is it that you need to achieve your mission. The production processes are selected to meet volume and product requirements, okay? And in this case, we have to think about quality, flexibility, the costs, and those factors will influence the kind of process that we use. We need to then consider the role of the employee in the process, and then how we train, develop, empower that employee to be able to deliver the best performance through that process. So you have to design the process with the employee in mind. The two things are not mutually exclusive. And then, of course, where it's possible, you could apply lean techniques. And what do we mean by lean? Lean is about minimizing waste. So value stream mapping is a very useful tool in lean analysis that helps you to minimize the amount of waste in a process, because waste means cost, waste means inefficiency, waste, and not just in for-profit organizations, not for profits as well. If you are, for example, are providing disaster relief right now, we've just had some hurricanes hitting south of the border in the United States. Well, you have to have processes that focus on delivering goods and services to people in distress. And so you have to look at these processes and minimize waste, minimize non-productive time. And so an examination of your process can lead to great performance in that case. All right? So we've just introduced you to process strategy and why it's important, and recognize that all goods and services are produced from a process, and it has to be in alignment with the mission and the vision and the strategy of the organization.